Okay, here I have 2 points, 3, 2, 0, and 0, 1, negative 2. Let's call this point A and B. Okay, and I need a plane that contains these 2 points. Now, of course, you need 2 points to determine a line, and you need 3 points to determine a plane, right? If you're given 1, 2, 3 points in the space, there should be only one unique plane passing through all 3 points, right? But here we're given just 2, so if you have the line that's connecting A and B, then the plane can just be containing that line, but it can rotate around it, right? There's you actually have a 360 degrees of freedom, and we don't know. Yeah, we don't know which one's parallel to the x-axis. Okay. All right. So what does it mean to be parallel to the x-axis? Well, so one way to say it is, like, if you start from any point and you move in the direction of the x-axis, that point still should be in the plane. So what it's saying is that here's A, and then here's the direction of the x-axis. Now, the direction of the x-axis has the I vector that's in the same direction, right? So you move I vector, and you move to another point, and that point better still be in this plane. That's what it means to be parallel, right? Okay. So we know that I is a vector that's parallel to the plane. Another one is, let's call this vector u. So here's I vector. Let's call this vector u. What is vector u? Vector u is terminal minus initial. So 0, 1, negative 2 minus 3, 2, 0. And that gives you negative 3, negative 1, negative 2 as another vector. And I like this because if you have 2 vectors that's embedded in the plane, what's the equation of the plane? The equation of the plane is a times x minus x1 plus b times y minus y1 plus c times z minus z1, right? Where x1, y1, z1 is any point on the plane, right? What's the meaning of ABC? A comma B comma C is A. Forgot? It's a normal vector to the plane, right? It's a vector that's perpendicular to the plane, okay? So what we know is that if I have 2 vectors, one vector here, another vector there, then I can do the cross product of the 2, which will give you a vector that's perpendicular to those 2 vectors, which will in turn will give you a vector that's perpendicular to the plane itself, okay? So that's how you can quickly get a normal vector, because I know that cross product gives you the normal vector to the 2 vectors, right? So here's what I'm going to do. I'm going to put I, J, K, and then 1, 0, 0 is this vector. And the other vector is negative 3, negative 1, 2. Okay. And in this case, I think it's better to expand in the second row because I have 0 and 0. Right? So that just gives you, and remember the checkerboard of signs is plus, minus, plus, minus, plus, minus. So this one should have a minus there, minus 1. And if you get rid of the column and the row containing them, you get JK and negative 1 and 2. JK, negative 1 and 2. So that gives you negative 1 times 2 times J minus negative 1 times K. Right? It's AD minus BC. Okay, so that's going to give you 0I. There's no I here, so it's 0I, negative 2J, and negative 1K. Okay, so that's That's going to be your ABC. So now let's try to write down the final answer just from these. And I'm going to choose this point A as x1, y1, z1, okay? So now the answer is, it'll be 0 times x minus 3 plus negative 2 times y minus 2 plus, what is it? Negative 1 times z minus 0 equals to 0. Well, this is kind of meaningless because 0 times anything is 0. So you have negative 2y plus 4 minus z equals to 0. And then I will just move these to the other side. So you get 4 equals to 2y plus z as the final answer. Okay? That's the final answer. Okay, here's a similar question. Find the equation of the plane passing a point and containing a line. So this is very, very similar to the previous one because I have a line that the plane must contain, but there's a third point. If I call this point A is this third point. Okay. So one way to do is, again, we're going to apply the same idea. Just find two vectors that's inside the plane, and then take the cross product that gives you the normal vector, and then now you can just plug it into the equation for the plane, right? The problem is, I know this directional vector. What's the direction of this line? I mean, I know this is a line. Why is it a line? Because if you differentiate, what do you get? You get 3, 5, negative 1. So this is a moving particle that has a constant velocity, which means not only the magnitude doesn't change, the direction doesn't change. Constant velocity is different than constant speed, okay? Constant velocity motion can only go on a straight line because its direction never changes, right? Okay? So I know that this is a line. How would I know its direction then? What's the direction? If you know, just say. I know some of you know this answer, but are too polite. What's the direction of this line? Come on, you know, right? What's the direction of the line?
Same as I.
No. This is a different question. Sorry. You know that this is a moving particle, right? Because for each value of t, it gives you a location of the moving particle, right? Yeah. And direction of the line means it's the vector that's pointing in the direction of the movement, right? What is the direction of the line? Yep.
ABC.
What is ABC?
3, 5, negative 1.
Yeah. Why is that? Because that's what you get if you differentiate, right? If you have something moving, then you differentiate, you get the velocity that way. And velocity must be the direction of the line. Obviously, right? Was that hard? No, yeah, just differentiate. That's 3, 5, negative 1. That's the direction, okay? So I know that this direction is 3, 5, negative 1. So I have one vector to play with. But given the previous question, I need two vectors to get the normal vector because I have to do the cross product, right? So in order to do that, I need to come up with a vector that's like this, okay? Which means I need to choose a point from that line. Okay? So can you give me any point on this line? Who can give me 1 point on this line?
1, 3, negative 1.
1. No, I got something backwards. Yeah.
1, negative 1, 3.
3. How do you get that?
Plug in 0 for 2.
Yeah, because at each moment in time, this particle is someplace in the 3D space, and the trajectory is a line. That's what's happening, right? And if all you need is this one single point, why not just take t as 0? That seems to be the easiest one, right? Yeah. So that's what you pick. So take t as 0. But of course, you can pick other things. If you wanted, you could pick t as 1 or t as -1, -10. You're just going to get bigger numbers, but you can still get the same answer that way. All right. So I'm going to say this vector is u, where this point is, as you said, this point is 1, -1, 3, which is what you get if you plug in 0 for t. Right? And then vector u is therefore going to be terminal minus initial, so 1, 3, -1, -1, -1, 3. So that's going to be 0, 4, -4. So that's the vector u, and because I need to get a normal vector, let's just take the cross product of these two. So the normal vector is now going to be ijk. Just put this 3, 5, -1 here, and then put 0, 4, -4 here. That's going to give us the normal vector. Okay, and then we can expand in terms of I, so it'll be I times 5, -1, 4, -4, minus j, minus because of the checkerboard of the signs, right? And then you have 3, -1, 0, -4, and then plus k, it'll be 3, 5, 0, 4. Okay, so let's see what we get. You get -20 plus 4, so it's going to be -16i. This will be -12 minus 0, but there's another negative, so it'll be plus 12j. This will be plus 12k. So that's going to be your normal vector. A is -16, B is 12, C is 12. Now in hindsight, because you just need the direction, you could have said, well, both of these are divisible by 4, so why not just take 0, 1, -1? There will still be a vector that's parallel to the plane, so that could have been another way to get it, okay? All right, but anyways, those are your A, B, C, so it's -16, x minus, I'm going to choose this one as x1, y1, z1, so it'll be x minus 1 plus 12, y minus 3 plus 12, z minus -1, which is z plus 1 equal to 0. Okay, and then let's divide by 4. Actually, let's divide by -4. So you get 4x minus 1 minus 3, y minus 3 minus 3, z plus 1 equals to 0. And because I ran out of space, let me just erase this and put the answer here. The answer would be 4x minus 3y minus 3z equals to, let's see, 4 plus 9 minus 3, 6 plus 9 minus 6 minus 4, 2. Oh, it's going to be -2. I think that's the answer.